Hello peoples, how y'all doing? Today we're going to be doing hash maps. First I'm going to go through conceptual. So for the midterm, I don't think he's going to have you create a hash map from scratch. So I'm not going to be doing that, but what I will be doing is just explaining how to use it, what's the fundamentals, how does it work. So what is a hash map? A hash map is actually just an array. So it's an array that looks something like this. And you have index 0, index 1, let's say 2, 3, 4, 5. It's a fixed size index that does resize. Every time you want to make it bigger, you have to copy it into a bigger index. Like, so you have to copy whatever the index is, whatever the array is, and then make it bigger, and then copy your values there. Now, how does a hash map work? Let's say it works in key value pairs. So you'll have a key and you'll have a value. The key is what you use to access and change the value. All right. So let's say we have 100, 105. The keys can be integer or string, so it doesn't really have to be a string. You can just have it as an integer. You can also have it as an object. So 110. Let's do 115. So it's 4. Yeah, actually, I'll just make this shorter. So now that's 4. We need 2 more. So 220. And let's say 101. It doesn't matter the order. Okay, and our values, we'll just, it can be anything. So I'll just put it, anything really. It can be an object, it can be a string, it can be a number, it can be just a character. So it doesn't really matter. Okay, so now that we have our list, our little key value pairs, what we want to do is store them in our hash. So how does the hash map do that? So there's something called a hash function, and you always need a hash function. The hash function takes in a key, not a value, but a key. And out of this key, what happens, let's say I pass in 100. So my key is the string 100. So I will take the string and I will convert it to a number. So I believe you could do, what was it? Like you can do 4. So you'll do a loop. So you could do for character, okay, maybe I should type this instead, so it's a little bit easier to read. Hello, whoops. So you'll do for character C in key. So we'll be going through every character, and unfortunately I forgot what the function was, but what you want to do is convert the C to integer. So you want to get the ASCII value. Once you get your ASCII value, you'll have like a result, and you'll add all your values to this final result. So let's say our 100 string is equivalent to the integer 587, let's say. Okay? So now after I do this, what do? What I do is I take 587 and I modulo it by the size of the array, not the index. So it's not 4, it's the size. The size is 5. All right, so it's going to be modulo 5. And this will give me a number between 0 and 4. All right, now once I get a number between 0 and 4, I will do, okay, so the array I have up here, I'll do array at whatever this returns. So let's say this returns 3. Okay, so I'm going to do array at 3 equals, and then I add the key value pairs. Now we know in an array, you can't add a key and a value within the same indice. So we create something, you can think about it like a node. It's like a linked list, it's like a node. And then in the node, you can think about it like it's a node, right? And the node holds the key and the value. All right, and so now every time you put in 100, this function will return the same index. And so every time you try to access something in the hash map, you'll give it the key 100, right away it'll convert to an index. And we know if you want to access something from an index, it's in O of 1 time. It's constant, it's instant, right? It doesn't take any time. Now, what is the issue? Well, here, let's do, so let me copy this. What is it? Because remember, nothing in code is perfect. Everything has pros and cons. The question is, what is the pro and what is the con in this? Here, actually, let's go to the side. All right, now, here, let me spread these out more. Okay, now, let's say I have my key value pairs right here, which I had 100, and it was, I believe, dog. And you know, I have all this. So I had 6. So if I remember, I had 6 key value pairs. So that's 1, 2, 3, and 4. Oh, well, 5. And that's the 5th. Okay. Now all these are key value pairs. Now what happens if I want to add the 6th one? This is key. Okay, you guys get the point. Now, what if I want to add the 6th one? What happens? Your list won't actually resize. I mean, if you're using the hash map in Java, then it will automatically handle all that. But if you're like fundamentally, what you'll get is something called a collision, right? So what is a collision? A collision is basically when you add something, either there's no space, or the key you gave into the hash function. Remember earlier we have a hash function that you pass some key and it gives you an indice. If the key you put in, let's say 100, the key 100, when you put it in, it gives you indice as 0. And what if you put in another string that is, it can be anything. It can be like hello. Any other key, right? And what if this also gives you index 0? What if when you put both of these into this function, they all give you the same index? That's when you get a collision, right? And so how does a hash map handle a collision? What it will simply do, it will still put it at index 0, but remember how this was like a node, the linked list? So what it will do is it will simply link it, and it will add your second key here, which is the hello with its value. Okay? Now, when you search something, remember how I told you it'll give you the indice and it will go and grab it? But HashMap isn't just, it doesn't only go by indices. So first you'll pass in into your hash function. Let's say I pass in hello as the key. So let's say I pass in hello as the key into the hash function. This will in turn give me the index 0. So my hash function will go to 0, or will go to the first one and I'll be like, is this key the same as this key? No. Then it will iterate. Is this key the same as this key? Yes. So then it will return you this value. All right. So that's how collisions work. Now, why is collisions bad? Is because remember, if you only have one node and you give it an index, it won't need to search through the linked list to get your value, right? Like what if you have a lot of collisions? The way it searches, remember, it searches linear, right? So if you have multiple collisions and you have a long chain, then what will happen is you'll get a linear search, which will slow down your retrieval time. So it will go from, so O1 is the average case. Unless your hash function is very bad, well, it will give you a lot of collisions, or your array is very small, where you just simply can't fit unless you have a collision, or like I said, you put a string, like 2 strings that give you the same key, and that will also give you a collision. Now, how can you avoid collisions? Obviously, improve your hash function so that it will always give you a different hash for the key. It won't give you the same index. The second way is making obviously your array bigger, because then your keys will be more spread out. Because instead of doing modulo 5, where you have options between 0 and 4, you will do the size. Let's say the size is 10 now. Modulo 10 now will give you between 0 and 9. And so you see how this is less likely to get collisions comparing to this. And so that's really all hash maps are. It's just a linked list that is being held by an array. And I believe I haven't forgotten anything for hash map. Now, how do you use it in code? So to create it, you'll just do hash map, and you'll pass two things. You'll pass the key and the value. So as in types. So what is the key type? Right, so my key type, let's say I want string and I want integer. Or I could do the other, integer. Let's say integer is like phone numbers and the string is names. And then here I'll have my contact book, and this will equal to new hash map, right? So you see, if you hover over it, it will give you, it's an initial capacity of 0, and it's a load factor of 0.75. So what is the initial capacity? What does that mean? That means that's the array. That's what it's talking about. And I believe here you could always change it if I just put 20. Yeah, initial capacity. So now I just made it bigger. But for now, we'll leave it at the just the default, which is 16. Now, what is a load factor? A load factor basically says when you have a array, let's say it's 10. So 0, 1, 2, 3, 4, 5. Actually, I don't know why I keep doing that. I can always just do. There you go. Okay, so it's of size 10. So what a load factor of 0.5, it means once you fill, let's say you have a key value pair here, you have a key value pair here, all of these have key value pairs, and then you get to the 7. Now you're 70%, or well, this would be 80%. You're 80% complete, as in full. So once you get the 80% mark, what happens is the built-in hash map will resize this such that you maintain the 0.75%. So you'll never have 100% full. All right. Now they do that, like I said, is to avoid collisions, because the bigger your array is, the less often you get a collision. All right. So what are some functionalities here? So first, let's fill them up. So how do you fill it out? You'll do the name, contact book, dot, and you'll see you have all these options. You can do put, and in the put, you'll put, remember, we have an integer and we have a string. So let's put a phone number. 911 2 3 4 5 6. Actually, we'll just go short numbers. Let's say just the first 3 digits, 647, and their name is going to be Bob, right? So that's our first contact. Let's copy this a couple times. Let's make it here John, Lord, Jesus, and then here we'll do 911, 416. I'm going with area codes. What was it? 905? There you go. So now we have basically filled out our hash map. Now let's see what happens if you do system.out.println and I do contact book. What will that give us? As you can see, it gives you 406 Lord, 647 Bob, and so on. And as you also see, the way it printed it is not in the same order we put it in, because the order just depends on the hash map. So once you hash the code, what does that give you? That's how it works. So you see, for solid integers, 416, it's in order, 905, 911. That is for solid integers. But if we were to convert these to hashes, to string, sorry. Let's do that. Oops. Oh, there you go. And then we're going to change this to string. Now we can, as you can see, now it's in the order that we put it in, but that's not necessarily always the case. So it just depends on how the hash map kind of put them in the array. Okay, so that's that. Now you have other functionalities. You could do contact. Here, let's use the. You could do contact book dot get, and you'll give it a key. So let's say 647, and this will return you the key. So you see it returns Bob. Now what if I put something that is not in there? It returns null. Okay. Other functionalities you have remove, where you just say remove. Here, let's give it here. We're gonna remove 648. So this is not even in there. And that returns null because obviously it's not in there. So then I can do 647, give it that key, and as you can see, it got removed. There is other things like contains key. So that one you will put a key. So it's just like contact book dot contains key, and you give it a key, and it will tell you true or false. Like, does this key exist or does it not exist? Like this, and it will tell you if this is in the list or not. You do have also is empty. So I could do contact book dot is empty, and this will basically tell me if my hash map is empty or not. The other thing is size. I could give it size. So let's do. There you go. Whoops. And if I run this, as you can see, it gives me 3 because I removed Bob. So it doesn't give you the size of the array, which is 16. It gives you the size of how many things are in there. Put if absent. So this one, I don't think you're going to be using this one, but it's put if absent. And the way this one works is you give it a key value pairs, and if the key doesn't exist, it will put it in there. And if it does exist, it will simply not do anything. The put, however, the contact book dot put, this one, if you give it a key that's already in there, it will change it. So see if I do 647, and instead of Bob, I do boobs. And here, let's print out. Let's not remove it. And there you go. So as you can see now, 647 just says boobs. You do also have key set. Key set is one you will be using if you want to loop through a hash. So it's key set. And here, actually, we'll print this one out. System.out.print. So this one will basically print all the keys. So if I want to loop through and print only the values, what I'll say is for, I believe you could also do, yeah, maybe not. So what you can do is, because the string, the key is a string, so you say for string key n contact book dot key set, right? So now what you're saying, this returns a array of keys, and the keys are strings. So this will return an array of strings. And so for every string within the keys, the strings, I can do system.out.println, and then what I'll do is just contact book dot get, and I'll give it the key. And this will just print all the values. There you go. So you see boobs, Jesus, Lord, and John. And so that's how you loop through a hash if you want to search it. If you want to get the hash code of a key, what you can do is, here, let's print all the hash code. So I can do key.hash code. And here, let's print that out. System.out.println. And so this will print me the codes. And what I'll do, actually, I'll do tab. So I'll do plus a tab. So then there will be a tab. And instead of println, I'll just do print. Actually, we'll do println. And at the end, we will also print. What do we want? Contact book dot get. Or actually, we'll just print the key. There you go. So we know which key associates with which hash code. And as you can see, these are the hash codes, which is, so you see 647, once it's put into the function, it will give you 53561. These are integers. One more thing you could do is, I believe if I take this, since the size is 16, let's see if I modulo this 16 and see what I can get. There you go. So you see, these are my indices. So you see, I do have actually 3 clashes between 647, 911, and 416. What we can do here is, let's go back to an integer and see if we're getting any clashes. Or, well, not clashes, like collisions. So we'll have to this and change this to integer. And we'll also have to change this to integer, since the key is now changed to integers. Okay, I gotta remove this. Gotta remove that too. Okay, and as you can see now, I don't have any more collisions, 0, 7, 9, and 15. And so here, let's do, if I do 20, I'm gonna set the size to 20. And so I do module 20 here. And you see now it's 16, 7, 5, and 11. These are their positions in the array that is out of 20. And that's really it for, what do you call it, for hash. You got put, get, remove, contains key, contains, you can also do contains value. So if I could do contact book dot contain, so if you're trying to search for a certain value, let's do Bob, and let's see if we get anything. Oh, I didn't print it out. So system dot whoops dot out dot print. There you go. And this would give you also true or false. So you see it returns true, and if I put something else, it will return false. And yeah, so you have contains value, you have is empty, size, put if absent, key set. Key set is very important. And if you want to get the hash, you'll do key.hash code. There are a lot other. So if you see contact book dot, you have clear, which will empty your hash. But most of these you won't really be using. So that's why I didn't really go through them. Let me loop through, see if there's anything that you might want to know. But I don't think you'll need to. Size, yeah. You don't need, so the ones I covered are all the ones you need to do most of the basic functionalities you'll be tested on. And that's HashMaps. Thank you for listening. I'll see you guys. So after this, I'll be doing the midterm review. And that's about it.